Well, I'd like to start things by thanking you for taking the time to attend today's presentation. As you see on the screen, my name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models, including the very latest models incorporating new cutting-edge technologies. And one of those models would be the one you see on the screen right now, but we will get to that shortly. First off, let me say that over the years, I would typically begin these presentations with a discussion of the importance of STEM education, changes in the manufacturing environment, and the growing need for highly skilled workers in the modern workforce. But at this point, I really think it's pretty well established just why technology-focused education is so necessary. And so with that in mind, I'm going to dispense with any preamble and pretty much jump right into the discussion of what fischertechnik is, and then I'm going to show you each of the current models that are available in the simulation family. Now, fischertechnik simulation models have been designed with the intent of providing a compact, engaging, and a hands-on method for teaching and demonstrating high-end automated systems. The line itself consists of a series of pre-assembled small-scale models which are designed to replicate, both in appearance and function, various automated robotic machines and systems that are commonly used in commercial manufacturing. Now, before we look at each of the models, though, let me just provide you with a little bit of background on exactly what fischertechnik is. Fischertechnik has been creating tools for teaching students of all ages about technology and how things work for well over 50 years, all based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where they're designed to the components are essentially designed to simply stack. The fischertechnik system was created with more of an engineering mindset. And the core building block in the system, like you'll see on the screen right now, is designed to enable attachment from all 6 sides. And because of this, it allows for almost limitless design possibilities. Many of the parts used are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available will also help technical builders to address very specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who of course you see on the screen, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, had held more patents in his name than Thomas Alva Edison had amassed during his own lifetime, so that's pretty impressive. Now, prior to creating fischertechnik, Mr. Fischer was first noted as the inventor of synchronized flash photography, and that was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. Of course, any of us probably use them in our own homes. His company, the Fischer Group, continues to employ thousands of workers all around the globe, producing many variations of fastening devices used in building construction. And they also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik building sets, and that's whether those intended for the retail market or those intended for classroom use. In either case, the focus has always been on helping to foster an understanding of technology. Now, many of the products offered by fischertechnik specifically for the education sector are subject-specific sets that focus on different STEM-related topics. This could be things like mechanics, pneumatics, robotics, renewable energy, and so on. And many of these sets either include curriculum or they have detailed teaching and activity materials with them. And in most cases, students are asked to build a progression of models using the unique fischertechnik building system, and then they perform various experiments which allow them to explore and understand key aspects of those topics. The line of fischertechnik simulation solutions, which again are the focus of today's presentation, are something much different. The line consists not of kits, but of a series of pre-assembled small-scale models which are designed to replicate in appearance and function various automated robotic machines and systems. Some of the models found in the fischertechnik simulation line will include things like conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers several variations of an integrated factory simulation model. In these factory simulation models, 4 different workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with oven, and a sorting line with color detection are designed to all work together as one self-contained material cycle. We're of course going to take a look at these models, including the factory model, just a little later in the presentation. But before we do that, let me briefly outline some of the advantages of using fischertechnik solutions. First off, fischertechnik simulation solutions allow educators to offer engaging hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work or for having a tangible physical system to observe and work with in a programming or a PLC-focused learning environment. The models, once again, are designed to realistically replicate, and that's both in appearance and function, common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. And because the models are compact, and in most cases tabletop size, they're not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next factor is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each model is available in a 24-volt version for industrial users, with select models also available in a 9-volt version for those not versed in the use of PLCs. The 24-volt versions are designed for use with industry standard PLCs. So whether you use Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or many others, in any case, you can control these 24-volt versions with the PLC that you prefer. Likewise, just as you can use your choice of controller, you can also choose from the programming languages that you see listed on the screen now. Now, please note that with these 24-volt versions, in most cases, unless indicated otherwise, there's no PLC included, and any programming or programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. Of course, this shouldn't be an issue, as again, these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. Now, as I touched upon before, there are also 9-volt versions available of select models. In the case of the 9-volt versions, they will ship pre-wired to fischertechnik's own proprietary robotic controllers, which are the Robotics TXT controllers. And each controller in this case is going to be pre-programmed using fischertechnik's own RoboPro graphic programming software. In the case of these 9-volt models, the only additional component that will be required is one or more 120-volt power adapters, which we'll of course tell you how many you'll need when we discuss them. Otherwise, in most cases, these 9-volt models will essentially be ready to use right out of the box. Now, if you're involved in demonstrating or exploring IoT, which is of course the Internet of Things, besides the fact that many end users in the past have adapted models in the primary line of simulation and training solutions to use them for IoT purposes, right now fischertechnik also offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud control and what is often referred to as Factory 4.0. In the case of these models, they're designed to be both controlled and monitored from a special web-based dashboard. We're, of course, going to discuss this in more detail just a little later in the presentation. And finally, fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look at any of the other hardware-based industrial simulation options available in the marketplace, you'll probably notice pretty quickly that the actual entry point for many of these products can easily be $20,000, $30,000, $40,000, or even much more. fischertechnik simulation models, on the other hand, start at just a fraction of that price. And again, they're compact, realistic, and high-quality learning and demonstration tools. So on that note, let's look at each of the models which are currently available. Now we're going to begin with a look at some of the more basic modules, and then we're going to work our way up to the larger factory models, and which again consist of several individual workstations designed to showcase an entire production cycle. And then at the end, we're going to get to the very newest models. So if you want to see the very latest, please stick around to the end. Now we're going to start off with the classic line of fischertechnik simulation models, and the first model in the line is the basic conveyor belt, which you see on your screen now. This is a transport belt with a length of 275 millimeters, and it's used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as you may desire. Components on this model will include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 14 by 10 by 4 inches, and it has a weight of right around 2 pounds. This model is available in both a 24-volt version with a multi-pin connector. In this case, it will be 26 pins with a 2.54 millimeter grid, as is shown here. And again, the 24-volt version of this model, as well as many of the 24-volt versions that we're going to look at today, will require you to provide the PLC and the programming. And there is also a 9-volt version, which is connected to a pre-programmed robotics TXT controller, as shown here. In this case, one 120-volt power adapter is required for operation. And I will mention that for this and for all of the models that we're going to look at today, the specs are also detailed in the product listings found on the Studica and the fischertechnik.biz websites, as well as in our product brochure, which I'll provide information on obtaining at the end of this presentation. We'll be happy to send you a PDF version of that. But again, we'll give you information on that a little bit later. The next model we're looking at is the punching machine with conveyor belt. And this is a variation of the conveyor belt that we just looked at, except this time with a machining station built onto it. Components on this model will include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions of this model are approximately 15 by 12 by 7.5 inches, and the weight in this case is about 3.5 pounds. Again, it's available in the 24-volt variation with a 26-pin connector and a 2.54 millimeter grid, as shown here, and the 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station along with 4 conveyor belt sections. Other components on this model include 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 by 11 inches, and the weight is about 8 pounds. Again, it's available in both the 24-volt version with a 26-pin connector and a 2.54 millimeter grid for use with a PLC, and a 9-volt version wired to the pre-programmed robotics TXT controller and requiring one 120-volt power adapter. The next model we're looking at is a variation on the idea of a pick-and-place robot, in this case the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces it picks up in 3-dimensional space. The degrees of freedom for the model are as follows. Axis 1 turns 180 degrees, Axis 2 can move forward or back 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model will include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. The dimensions are approximately 19 by 16 by 9 inches, and the weight is about 6 pounds. Now, as with the other models we've looked at, this is again available in both the 24-volt version with the 26-pin connector and a 2.54 millimeter grid designed for use with the PLC and the programming of your choice, or a 9-volt version wired to a pre-programmed robotics TXT controller and requiring one 120-volt power adapter. The next model we're looking at is the vacuum gripper robot, and this time we're going to start with some video. Now, as you're going to see in this video, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. Models designed to precisely pick up and position workpieces in 3-dimensional space. This model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. The dimensions are approximately 9 by 19 by 15 inches and it has a weight of about 7 pounds. The 24-volt version of this model, as well as all of the 24-volt models we're going to be looking at moving forward, each have a relay board for motor polarity reversal and both a multi-pin connector, in this case 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, the 24-volt version of this model, as with all 24-volt versions, will require you to provide the PLC and the programming. And in this case, unfortunately, there is not a 9-volt version available. It's only a 24-volt. We'll just let this play through and we'll move right along then. If you do have any questions as the presentation moves on, feel free to type them in the webinar chat window or the question and answer window. Sometimes I can get to them during the webinar if it's, if I can stay on track, and other times I'll basically answer them at the end of the presentation. And there we go. The next model we're looking at is the automated high-bay warehouse. The model you're going to see here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays and 9 individual storage spots. Components on the model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, along with a selection of different colored workpieces and carrier trays for each. I will mention that this model has been a favorite among educators that we've spoken with who teach PLC programming, and the reason for that is probably pretty apparent because it gives the students a lot of very specific coding tasks that they have to address. Things like the precision of the precise movement of the picker arm, the precision where you have to store and retrieve the various work pieces from the shelves, things of this nature. Getting back to the model itself, the dimensions for the model are approximately 19 by 28.5 by 15 inches, and it has a weight of about 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And again, you will need to provide the PLC and the programming. And there is a limited release 9-volt version still available, which ships pre-wired to a pre-programmed robotics TXT controller, and one 120-volt power adapter is required for that. Next up is the multi-processing station with an oven. The model in this case features a furnace simulation with a pneumatic sliding door. There is a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of about 11 pounds. Again, it's available in both 24-volt versions for use with the PLC of your choice, with, once again, a relay board for motor polarity reversal and both a multi-pin connector. Again, this is 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And the 9-volt version in this case is connected to 2 robotics TXT controllers, so 2 120-volt power adapters will be required for all operations. We'll let this play through a little bit here. And there we go. The next model in our progression is the sorting line with color detection. Let me just see. Okay, we're good to go. And this simulation features a system for detecting workpieces of different colors and sorts them via conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as previously, the 24-volt version again has a relay board for motor polarity reversal and both the multi-pin connector, that's 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And again, the end user must provide the PLC in the program. In the case of the 9-volt version, it again comes pre-wired to a pre-programmed robotics TXT controller, and one 120-volt power adapter would be required with that. Again, as we move through the presentation, you'll see that the models being offered get more sophisticated and more elaborate. And the next model will be taking things up a step. This is, of course, the factory simulation, which combines the last 4 models we've reviewed. Again, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection. They're all combined into one self-contained material cycle. And the cycle you're going to see in the video works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then they get moved to the multi-processing station with oven. And after the work piece has been processed by the multi-processing station, it's then sorted by color in the sorting line with color detection before again being moved by the vacuum gripper robot back to the automated high bay warehouse for storage. Now, as we've already discussed the components of each of these substations previously, I won't belabor it by restating them here, but what I do want to discuss are the dimensions of this model as a whole. Now, as it again combines 4 individual models into this one work cycle, and they're all, of course, mounted on a board, it has a much larger footprint. In this case, the footprint of the model is approximately 39 by 31 by 16 inches, and the weight on these is between 43 and 46 pounds, depending, of course, whether we're talking about the 24-volt or the 9-volt version. Now, due to these dimensions, and this will apply to any of the factory variations that we're looking at. So when you see any factory model at any point in this presentation, know that it must be shipped flat as freight on a pallet. And another thing I'll mention, we'll talk about storage systems for this. Know that even with a transport case, you always will want to ship these models flat on a pallet to protect them. I also want to point out that with any of these factory simulation models, certain times of year, we can get a lot of demand for these. They're all, of course, as I mentioned, hand assembled. So sometimes you have to look at a 2 to 3 week turnaround between when you order these and when they get shipped out. Again, I will mention that it's available in a 24-volt version and no 9-volt version on this one currently, sorry to say. Again, as I was talking about the travel and storage case, I'm going to discuss that over here. The travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. And the lower portion of the case is lined with hard foam, and it's basically designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and the empty case has a weight of about 53 pounds. So essentially, if you put a factory model into this case, a regular factory model, the one we just looked at, you're looking at about 100 pounds total. And again, please note that even when using the travel case, these models will always need to be shipped flat on a pallet to protect them from any possible damage in transit. Want to be very careful with that. Now, the next group of models we're going to look at focus specifically on the area of IoT, and these are called Training Factory Industry 4.0. And this group of models was designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model that you just looked at, such digitization activities can be simulated, learned, and applied on a small scale before they're implemented on a larger scale. Now, as the following video does provide a nicely narrated overview of exactly how this factory works, I'm going to back off for a moment and allow you to watch and listen to the narrator.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node Red. In Node Red, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Okay, so just to summarize things briefly, here are some of the topics, areas which can be addressed with the fischertechnik Training Factory Industry 4.0. You can address training and simulation on a realistic production model. You have in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices. You learn about using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, connection of upstream and downstream logistic processes, and for experts, you have the creation of your own unique programming using C, C++. Now, as you just saw, the model incorporates many features not found in the models that we've discussed previously, perhaps most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples of things that you wouldn't see in the previous models would be the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. There's also the use of NFC chips in each workpiece, which enables the position of each workpiece in the work cycle to be mapped, and the use of MQTT, or message queuing telemetry transport, that allows the network TXT controllers to communicate with each other. Now, in regards to the 24-volt version specifically, I should note that it's a bit of a hybrid in that while using a PLC for operation and control, it also does incorporate one fischertechnik Robotics TXT controller. And in this case, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED, and this allows the option for not only presenting and using data on a dashboard in the fischertechnik cloud, but also to be able to display data and calibrate the stations of the factory in a Node-RED dashboard. And the model also incorporates newly developed 24-volt adapter boards to interface to the PLC, and these, of course, do ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows for the speed of the encoder motors to be controlled via PWM, or pulsed width modulation, and they also have push-pull output stages for phototransistors and buttons. Now, unlike the previous 24-volt models that we've discussed, the new 24-volt Training Factory Industry 4.0 includes access to a sample program. And in this case, the sample program is in structured text format, and it was created based upon a Siemens S7 1500 PLC. Now, all of this programming is available for download on GitHub. And of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some adjustments to the sample program, and the source codes needed for this are also available for download from GitHub. Now, all of this information and much more is included in the 152-page PDF manual, which can be downloaded from the fischertechnik website, and which is also available from us upon request. So, as I mentioned a brochure before, you can also request access to this manual, and I'll be happy to provide that, how you can get that at the end of the presentation. And I also need to mention that as of last year, there are 2 additional versions of the 24-volt model, which are also available. And I'm going to discuss those 2 options when we provide an overview of the costs of each of the models. Now, in the case of the 9-volt version of the Training Factory, the control is facilitated through the use of 6 robotics TXT controllers. Now, again, all of the programming is preloaded with the 9-volt version, so that once the connections to the internet and the cloud-based dashboard are made, all of which is, of course, clearly outlined in the downloadable documentation PDF, once you do this, you should be able to get started pretty quickly. The 9-volt version will require the addition of 3 120-volt power adapters, and while it should go without saying whether we're talking about the 9-volt or the 24-volt versions, it's also required that the end user, of course, have the ability to access the internet, as well as having a tablet or a device for accessing a cloud-based dashboard. Just want to point that out. There is no dashboard included with this. You do need a laptop or a pad or a desktop computer, whatever it is that you're going to be accessing a cloud-based dashboard with. Just to finish things up, the dimensions for these models are approximately 39 by 31 by 16 inches. They have a weight of between 51 to 53 pounds, depending on which version we're talking about. And as with the 2 factory simulation models, which we discussed previously, we do recommend the optional travel case to help protect your model during transport or storage. And that is the Training Factory Industry 4.0 model, once again available in both 9-volt and 24-volt versions. Let me just get a drink of water here, because we have a few other things to discuss. The next model we want to look at was a recent addition to the simulation line, and this model incorporates cutting-edge technology that is quickly becoming a part of our daily lives. This is the quality control with AI system model from fischertechnik, and it's ideal for visualizing this complex subject area in a hands-on manner, as it creates a sustainable learning experience by linking theory and practice. Processes can be sped up, fault rates and costs minimized, and fault evaluation standardized. This fischertechnik sorting line comes with workpieces in 3 different colors, and the workpieces are each marked with 3 different processing characteristics, and there are also some that have fault patterns. What happens is that the workpieces are scanned by the camera and classified with the aid of the trained AI. Depending on the color, the feature, and the fault pattern, the workpieces are then sorted by the artificial intelligence on the basis of their quality features. The AI used is realized with machine learning in TensorFlow. The AI model is used, or the AI used is realized with machine learning in TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the fischertechnik TXT 4.0 controller. The model's sequence control is implemented in the RoboPro coding programming environment and in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications. And in this case, the training is done in Python, for which a sample project is provided for explanation. And that is the new quality control with AI model. Ideal training, simulation, and demonstration model for education and for research, and the visualization of AI systems, machine learning, and neuronal networks. Are available only in a 9-volt version at this time, with a 24-volt version anticipated for release sometime in the later half of 2024. And I will mention that the 9-volt version uses the excuse me, I'm tripping over my mouth today. The 9-volt version uses the fischertechnik Robotics TXT 4.0 controller, and as before, one 120-volt power adapter is required for all operations. Now, the next model we're going to look at is a brand new release. This came out about a month and a half ago. It's been talked about since fall, but it was finally just released and is shipping now. And this is the Agile Production Simulation, the very latest iteration of the factory model, this time not only incorporating IoT and state-of-the-art manufacturing processes, but also AI, and this time also including a digital learning platform as well. The factory of the future is the subject of numerous research projects in science and industry. Forward-thinking companies rely on automation, modularity, artificial intelligence, and agility to remain competitive. Now, in order to promote these topics in industry and research, students, apprentices, as well as employees require the corresponding know-how and awareness to deal with these complex issues. And this is where the learning concept agile production simulation comes in. Now, it simulates processes such as quality assurance using artificial intelligence, as we just saw in the previous model. It incorporates the functioning of driverless transport systems, and it replicates automated processes on a small scale. And this can be from goods receipt to modular production to quality assurance. The accompanying learning materials translate this hands-on simulated processes into future skills for both students and for teachers. The digital twin of the model significantly intensifies the learning experience. Now, as we don't yet have the narrated video of this brand new model, I'm going to provide you with a quick overview, beginning with the module where incoming and outgoing goods are placed. And this is, of course, where the material flow of a workpiece begins and ends. The raw material is delivered at the goods receipt slot, positioned at the color sensor for quality control using the 6-axis robot with vacuum gripper. And I would mention this is a new addition, the 6-axis robot. In previous models that we looked at, we only had a 3-axis robot. So this new factory includes a 6-axis robot with a vacuum gripper. Again, the piece is encoded on the NFC reader, and the robotic arm then places the workpiece on the automated guided vehicle, or AGV as we'll call it, for further transport. The module also contains the central control unit, or Raspberry Pi, and the environmental sensor, which measures the different environmental conditions in the factory. And there's also an integrated movable camera on this unit, which can be swiveled in 2 axes to provide an insight into the entire factory via the fischertechnik cloud-based dashboard, which we saw an example of again in the previous video. Now, at the end of a cycle, a finished workpiece is delivered at the goods dispatch by the AGV. The next stop for a workpiece after goods receipt is usually the high bay warehouse. Although, because this is an agile production simulation model, this could differ if there was a need for doing so. But in any case, the high bay warehouse contains 9 slots for workpieces, a stacker crane, and a vacuum gripper that picks up the workpiece from the AGV at the docking station and hands it over to the stacker crane for storage. The workpiece is placed in a workpiece carrier for storage, and retrieval is done according to the FIFO, first in, first out principle. Now, I will mention that the gripper arm on this is different than in previous versions of the high bay storage warehouse that we'd seen, either the individual model or the one that's incorporated in the previous factories. This uses a separate robotic arm to place the piece into the carrier trays, and when we have the video ready, you will see that in operation. Next up, though, is the drilling station. This consists of a docking station for the AGV, a vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the drilling head. Now, after the simulated drilling process, the workpiece is transported back to the gripper on the conveyor belt, and the gripper then places it back onto the AGV. Next up is a milling station. This consists of a docking station for the AGV and a vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the milling machine. There, the milling of two pockets is simulated. Now, after this process, the workpiece is placed back onto the conveyor belt and transported back to the gripper. And the gripper again places it back onto the automated guided vehicle. And I will mention when we talk about these grippers, each of these stations has a different gripper. So it's not the same gripper. It's not like the robotic arm that you saw in the other model where it's used to move it around. Each of these substations will have its own gripper. The milling state, or excuse me, the next station is the quality assurance with AI station. And in the quality assurance module, a vacuum gripper places the workpiece on a conveyor belt, and it's transported underneath the camera and it's scanned there. Now, the workpieces again come in three different colors, red, white, and blue, with three machining features, either drilling, milling, or drilling and milling, as well as various fault patterns, as you saw in the previous model. And again, these pieces are classified using the trained AI. Now, depending on the color, the feature, and the fault pattern, the workpieces are then either placed back onto the AGV as being okay, acceptable quality, or they're sent to the reject container as not okay or defective. The AGV then transports the workpieces from one module to another. Now, this is the AGV here. So it's a little robotic model that moves along. As you see, it's a track-bound vehicle that follows the printed black track. So it's not, it just basically, it reads the black track and it knows how to link up with each of the stations. It uses ultrasonic sensors to detect obstacles, and the vehicle also has omni wheels, which allow it to move in all directions. Two buttons and a photo transistor will help the vehicle dock to individual factory modules. Now, the AGV receives its driving commands from the central control unit, which is an industrial standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as its power supply. Now, when the battery of the AGV runs low, it navigates towards the charging dock, where it is automatically charged with a charger with charge monitoring. Contacts on the bottom of the charging station will connect the AGV with the charging electronics. Just to give you some of the specs on this, the power supply for the 24-volt is 11 amps. Central control Raspberry Pi is 4B. Individual model control is done by 5 SPS Siemens S7 1200 PLCs. There are also 3 TXT 4.0 controllers for sensors and camera, as well as a cloud-based access in the WEWA module for quality assurance with AI and for automated guided vehicles. There is a WLAN router for WLAN network. The software includes SPS programs and structured text, TypeScript for central control of the Raspberry Pi. There is Node-RED for communication between the SPS and the TXT 4.0 controller. There's Python for programs on the TXT 4.0 controller. And there's TensorFlow for supervised learning and quality assurance with AI. And again, there is also a digital learning platform with a digital twin of the APS model so that learning can be done with both the actual model as well as virtually. Now, we hope to have more details on this shortly when the video is available, but basically what you'll be able to do is there are certain aspects of it currently where you're going to be able to do the learning in either in the digital twin or on the model itself. There are some things that you can only do on the model itself right now. I will mention that the digital twin is going to have a floating license, so if you need multiple people to have access to the digital twin, that can be done. In any case, we're going to have more details on all of this, as well as an overview, a video overview of the product in motion. Very soon, we're working on that presentation. We hope to have that for you very shortly. But at least for right now, this gives you an overview of the Agile production simulation. Of course, with all this being said, you might well be wondering how much these models cost. So we're going to take a very quick review of each option I've discussed, along with the pricing for each. So let's review. First up, the conveyor belt in the 24-volt version. Again, requiring PLC, it's $354.95 each. The 9-volt version that comes with the TXT controller is $518.95. The punching machine with conveyor belt in the 24-volt version, needing a PLC and the programming, is $464.95. The 9-volt version with the pre-programmed robotics TXT controller is $599.95. The index line with 2 machining stations in the 24-volt version, that is not, $1,199.95, again, requiring PLC and programming. The 9-volt version, which includes 2 robotics TXT controllers, is $1,394.95. The 3D 3-axis robot on the 24-volt version is $1,059.95. The 9-volt version with the TXT controller, pre-wired, pre-programmed, is $1,369.95. The vacuum gripper robot, only available in a 24-volt version, is $1,199.95. The automated high bay warehouse in the 24-volt version, requiring PLC and programming, $1,448.95. The 9-volt version, pre-wired to the pre-programmed robotics TXT controller, is $1,318.95. The multi-processing station with oven in the 24-volt version, $1,287.95. The 9-volt version, $1,474.95. Sorting line with color detection, 24-volt version, $1,126.95. The 9-volt version, $1,128.95. The factory simulation, this is the standard factory, not the IoT version, not the APS version. So if that doesn't apply to you, you have a 24-volt version, does require PLC and programming. That is $5,149.95 for that. The full training factory industry 4.0 in the 24-volt version. Again, this is the one that's designed for industry 4.0 IoT with the cloud-based dashboard. The 24-volt version is $9,498.95. The 9-volt version, which comes pre-wired to those 5 robotics TXT controllers, is $498.95. I don't know why I'm tripping on that today. But there are 2 different variations of the training factory industry 4.0, which we have not discussed. These 2 are as follows. The first one has the PLC connection board and cabling. So as you know, that can get quite involved doing all the cabling and what have you. This variation includes the cabling, includes connection board, and it also includes, of course, I should mention all of these do include the sample version of the program in structured text format. The version with the PLC cabling and connector is $12,718.95. And finally, there is also a version of the Training Factory Industry 4.0 that comes complete with the Siemens S7 1500 PLC. This model in the educational version with the PLC, the programming, it comes with all the power supply, everything you need, pretty much everything to go, what have you. It is $19,319.95 in the educational version, available only to accredited institutions. For commercial use, the cost is $20,124.95 per unit. So again, with the PLC connection board only and the wiring, $12,718.95. With the Siemens PLC S7 1500, if you're in education, it's $19,319.95. If it's a commercial user, it's $20,124.95. Other items, 120-volt power adapters for the 9-volt models, and for a couple of the 24-volt models as specified, $12.99 each. The travel and storage case specifically for the factory simulation and training factory industry 4.0 models is $1,524.95 each. The quality control with AI model that we looked at towards the end, again, it's only available in the 9-volt version right now with the robotics TXT 4.0 controller. That is $2,249.95. Does require the power supply. 24-volt version should be available later this year. And finally, the Agile Production Simulation model is only available in a 24-volt version. This does include 5 Siemens S7 1200 PLCs and 3 fischertechnik Robotics TXT controllers, plus access to the digital twin, which you see a simulation of on the screen there. We're going to have, as I mentioned, a larger form presentation specifically on this model, hopefully very soon in the next month or so. In any case, your cost for this is $28,174.95. And there is also an Agile Production Simulation storage case. This is much different than the other case. It comes in, it's 2-tiered. This one is $4,024.95. And here is just some specs of what that model looks like. You can see that it basically allows you to take apart the model in sections here. The case is, yeah, it's a little bit different, but you see take it apart in sections. This one is more modular. And I will mention with the APS, there is the possibility of having some add-on units down the road and the possibility to buy an additional AGV for this. But again, that will be a little bit down the road. So at this point, if you do have any questions, I would ask you to use the webinar chat window or the question and answer window. Feel free to type them. I know this has been a long presentation, so I will go once, go twice. If I don't see any questions pop up, I will move to this slide about taking the next step. So if you'd like to request a full color brochure and current pricing, price list, if you'd like to ask any questions directly, if you'd like to request a quote or speak with your dedicated educational representative, you can do any of those things by calling us at Studica here, 888-561-7521. You can email us if you'd like to request a quote or any of this information. If you'd like to request a brochure with all the models, we can send you a PDF of the brochure. We can send you copies of the manuals for you to look over. You can email us about those at info@studica.com. That's studica.com. And if you'd like to connect with me, ask me about anything that I discussed today, something you wish I would have touched upon, any questions you might have about any of the simulation models or anything fischertechnik related, you can email me. My email is lance.zurek, so that's lance.zurek@studica.com. So on that note, thank you very much for taking the time to attend today's presentation. We look forward to hearing from you soon. Have a great day.